Lesson 12.2, Permutations and Combinations. One of the distinctive differences between permutations and combinations is that in permutations, arrangement is the key. For a permutation, order matters. So if you change one person, if you line people up for a picture and you change one person to a different location in the lineup, that is a brand new arrangement. In other words, a brand new permutation. Combinations, however, do not care. For example, if you have a track team, a relay team with 4 players or 4 runners, the arrangement of those runners, if that matters, who's starting, who's finishing, who's running the first, second, third legs of the race, if it's a 4x4, then that is a permutation. However, if you look at the group of runners, those 4 people, no matter how you rearrange them, it's still those 4 people. That is one combination. So if the order matters, we call it a permutation. If it does not, it's called a combination. There are 2 notations for each. Your calculators can do both. And the notation is NPR or P and then N comma R. Either way, it tells you how many there are to begin with. This is how many that are total. This is how many you will pick. Now you can do this with this formula, and this is what your calculator uses, or you can use the fundamental counting principle. Alright, so here's how we would use the counting principle. 8 people enter the Best Buy contest. How many ways can blue, red, and green ribbons be awarded? Now notice that they are only awarding 3 places. So first place, at the beginning of this contest, there are 8 people that could win it. After the first person wins, you have 7 people vying for second place. And then once that person wins, you have 6 people to choose from for the third place ribbon. And the counting principle would take the product of those 3 numbers. In your calculator, you would choose 8 people, picking 3 of them. And in both cases, you would get the same answer, 336. Your formula would basically say 8 factorial over the difference in the 2 numbers, which is 5 factorial. And that again would end up with 336. How many different ways can the letters of the word banana be arranged? Now this one has a unique formula because the problem with this question is you have A showing up 3 different times and N showing up twice. And because of that, the same letter would show up, or if you chose 2 different N's, you would still have the same result. So you have to divide so you don't have as many. So here we have the total number of questions, or excuse me, the total number of letters, which is 1, 2, 3, 4, 5, 6 total letters, even though some are the same. And we go 6 factorial. Now, A shows up 3 times. So we will write 3 factorial to take care of the A's. N shows up twice. So we'll go 2 factorial and take care of that one. And this looks like a question that we did in our previous lesson. We have 6 times 5 times 4 times 3 times 2 times 1, which is 6 factorial. 3 times 2 times 1 for 3 factorial, and 2 times 1. And again, these are all multiplied. That would give us 3 times 2 times 1, canceling out. 2 goes into 2 once, 2 goes into 4 twice, and 1 doesn't have any impact. So our answer will be 6 times 5 times 2. In other words, 60. Alright, if they were just the word lost, all 4 letters are different, then you would just write 4 factorial. Combinations. Now, combinations does not care about order. Again, to emphasize, order does not matter. I could have a group of kids in a classroom and the seating chart would be a permutation, but the class list would be one list of those students, one combination. Here we have a question that says 5 cousins at a family reunion decide that 3 of them will go to pick up the pizza. How many ways can you choose 3 people to go? Now here they're not caring about order or arrangement, they just want 3 people to go. So here we have 5 cousins, and we will choose 3 of them. Now you have the ability to use Pascal's triangle on this. It is row 5, and it is number 3, or I should write third number after the 1. Now to show this, I want to take this 5 choose 3 and go to the next page for a moment. And here's 5 choose 3. Row 5, third number in after 1. So here's 1, 2, 3. So 10 represents how many different combinations you can have. So 10 is our answer. Now we could use this formula, which would be 5 factorial over the difference, which is 5 minus 3, so 2 factorial, and then again 3 factorial. That's the R. Because we're dividing by another piece, that would definitely make it be fewer terms, or fewer combinations. So 10 is our answer. 6 cards are drawn from a standard deck of cards. How many hands consist of 2 hearts, 4 spades? Now here we look at stages again. 2 hearts. How many different combinations of hearts are there? Well, there are 13 hearts, and you want to choose 2 of them. Spades, there are 13 spades, and you want to choose 4 of them. So Pascal's triangle would tell you that row 13, second number in after 1, is 78. 13th row, fourth number in, would be 715. And the counting principle says to multiply these 2 stages, which would give you 55,770. There are that many different ways to get a hand that has 2 hearts and 4 spades. And this ends lesson 12.2.